Okay, different types of data again. Cross-section, time series. Cross-section data is collected at a certain point in time across a number of units of interest. Right? Time series data is collected over successive points in time. Okay. Let me give you a simple example. Just say, I'm talking about the GPA of one student of a time. Just say the GPA of Tom is 5 in semester 1. Then in semester 2, he get 5.2. In semester 3, he get 5.4. Okay. GPA of a student over a certain point in time. That's what we call time series. Are you with me there? Okay. The GPA of Tom from semester 1 to semester 2 to semester 3. Time series. Okay. How about cross-section? I may have the GPA of 3 students in semester 1. Okay. So this is one point in time at a certain point in time. At a certain point in time, but across a number of units of interest. Okay. Notice what I said before. The GPA of Tom, Jim, and Ben in semester 1. Is that time series or cross-section? Cross-section. Right. I think I mentioned before, we'll be looking at some certain graphical techniques that would be more suitable for qualitative data. We'll also be looking at some graphical techniques that will be more suitable for quantitative data. So if you have qualitative data, what should we do? Okay, what graphical techniques should we choose? We'll be using pie charts or bar chart. Okay, pie chart is a very popular tool to represent the proportion of nominal data. Okay, so what is the objective here? You got your qualitative or nominal data, and you would like to display the proportion of the different category of your qualitative nominal data. Pie chart is the way to go. For example, okay, I may want to do a survey asking, what magazines do you read? So the response that I will be getting is, I'm reading New Idea, okay? Another person is reading New Idea, okay? Another person is reading Better Homes, and so on, okay? So first thing first, I will try to count the number of readers of magazine A, magazine B, magazine C, and so on. Then I'll try to work out the proportion of the number of readers reading magazine A as opposed to magazine B, magazine C, and so on. What better way to represent the proportion of the different category than drawing a pie chart? So again, the objective is what? Pie chart is useful to display proportion of the different category of your qualitative data. Does that make sense? Bar charts are an alternative to pie charts, where you can display the frequency or relative frequency of each category by a vertical bar. As simple as this. You have a bar chart here. Okay? On the y-axis, you got your different types of magazines. On the y-axis, you got the frequency or the number of readers that are reading the different types of magazines. So there you go, guys. I think this is a good presentation of your quantitative data set. If you got quantitative data, what to do? Let's look at this particular example. You would like to provide information concerning the monthly bills. Okay, so I'm talking about bills there. So that must be quantitative because we are talking about how much money do you spend on your mobile phone. Okay, so you would collect the data. Then I suggest you prepare a frequency distribution. Then you draw a histogram. What do I mean by frequency distribution? What do I mean by histogram? So suppose you have 200 data points. So you have 200 customers. Customer number 1 spent 42.19, customer number 2 spending 38.45, and so on. Okay? So you got 200 data points. To prepare a frequency distributions, you count how many observations that will fit into your different classes. What I mean by classes, you will see that in the next presentation, in the next slide presentation. But first thing first, guys, the idea here with preparing a frequency distribution, we would like to make different classes, okay? And then we will count how many observations that will fit into class A, class B, and so on, okay? How many classes to use? How many classes to use? I've got a suggestion table here. If you got less than 50 observation, you should use 5, 6, or 7 classes. If you got 50 to 200 observation, you should use 7, 8, or 9 classes. Okay. So today we have 200 observation. You can either use 7, 8, or 9. So I've chosen to use 8 classes. Right? The next thing that you have to work out is what should be the width of my class. Okay? There's a formula here. Class width is range divided by number of classes. Range is the largest observation. Just say the largest observation here is $119.63. Okay? And the smallest observation, just say that somebody spent $0. Okay? So class width will be 119.63 minus 0 divided by, remember, we agreed before that I'm going to use 8 classes. So based on the formula, you should be having a class width of 14.95. But I don't think it will be convenient for you to have 14.95. It would be much more convenient if you have a class width of 15. Alright? What I mean by that is, so there you go. How many classes did I use? 1, 2, 3, 4, 5, 6, 7, 8. Okay. What is the width of my class? 15. You should not use a width of 14.95. Because imagine, guys, if you use a width of 14.95, you are going to have this 0 up to 14.95. Then 14.95 up to 29 point something. Is that convenient? No, it's not convenient. So in deciding to use how many class width at the end, make it most convenient. 14.95 is not convenient. 15 is most convenient. Are you with me there? Okay. Frequency. So what I'm saying here, there are 71 customers that are spending 0 up to $15. Okay. 37 customers spending 15 up to $30. Okay. If you sum this up, all together, that will add up to 200. Is that right? Remember, we have 200 customers all together. Okay, good. Let me also make it clear. 0 up to 15. To be more specific, guys, I will write that as this. Any observation that is less than 15 but bigger or equal to 0. So once again, any observation that is bigger or equal to 0 but less than 15. Okay? So if you are spending $15, are you going to go to the first class or second class? If you're spending $15, you will go to the second class. Is that okay? Okay, what you see in front of you there is a frequency histogram. In a way, this looks like a bar chart. But it's not a bar chart, guys. Notice with bar chart before, on the x-axis, you have your different types of magazine. Right? But here, you are talking about your classes. 0 up to 15. Okay? There's a mistake here, guys. 15 should be there. Okay? So 15 should not be in the middle. It should be there. Okay? 0, 15, 15, 30, 30, 45, and so on. Okay? So the x-axis effectively is your classes. Can you have gaps on histogram? No gaps on histograms. Okay? On the y-axis, you got your frequency. Okay? Effectively, the frequency here is the number of customers. Number of customers that are spending 0 up to $15, 15 up to $30, and so on. This is what we call a histogram. Why do we do a histogram? As you can see here, now there's a lot of things that you can discuss between yourself and your boss. Okay? If you just get the data, it's just a bunch of numbers that does not mean so much. But when you do the frequency distribution table and draw the histogram, there's a lot of information that we can discuss. So histogram is useful to show the distribution of your data set. Once again, histogram is used for what, guys? To graphically show the distribution of your set of data.